Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P16F6 indicates a high voltage condition in the starter cut relay 2 control circuit for the Honda Civic model years 2011 to 2015. This specific error points to a potential malfunction in the starter cut relay circuit, which is crucial for the engine's starting system. The starter cut relay functions to control power to the starter motor, preventing the engine from starting unless conditions are met, such as the presence of a properly functioning key or engine immobilizer system. This component is typically located in the underhood fuse and relay box, where it is easily accessible for testing and replacement. Addressing this DTC promptly is essential, as failure to do so can lead to ignition issues, potentially leaving you stranded. Understanding the components involved, such as the powertrain control module, PCM, is critical for effective troubleshooting. The DTC P16F6 is associated with a high voltage condition in the starter cut relay 2 control circuit. This circuit is integral to the vehicle's starting system, as it ensures that the starter motor receives power only when appropriate conditions are met. The starter cut relay 2 is typically found in the underhood fuse and relay box, situated near the battery and close to other key components, like the fuses and various main relays. Its primary role is to control the power supply to the starter motor, which is essential for starting the engine. A malfunction in this circuit may disrupt communication between the relay and the PCM, powertrain control module, which manages engine functions and ensures proper operation. This error may arise from various issues, including faulty components, short circuits, or wiring integrity problems. Several possible causes can lead to the DTC P16F6 being triggered. First and foremost, a failed starter cut relay 2 is a prime suspect, which could be due to internal component failure, preventing it from operating correctly. Another common issue is a short circuit within the wiring associated with the starter cut relay 2 control circuit, which could inadvertently allow high voltage where it shouldn't exist. Poor connections at either the starter cut relay or the PCM may also result in unreliable communication or increased resistance, contributing to the error code. Additionally, intermittent failures due to loose or corroded terminals could temporarily allow normal operation, making it crucial to check these components thoroughly. Understanding these potential causes will aid significantly in the troubleshooting process. The symptoms associated with DTC P16F6 typically manifest as the engine failing to start. Drivers may notice that pressing the engine start-stop button yields no response, indicating a starting issue. Furthermore, if DTC P16F5 is also present, it suggests a related malfunction within the starting system that should be addressed concurrently. Additionally, some drivers may experience intermittent starting issues, where the engine may start on some occasions but fails to do so on others, leading to frustration and uncertainty about the vehicle's reliability. Timely diagnostics and proper repairs are essential in mitigating these symptoms, as they can lead to a more significant electrical failure if left unresolved. Recognizing these signs will help users understand when they should seek professional assistance. In the first step of troubleshooting for DTC P16F6, it's crucial to verify the problem conditions before diving deeper into diagnostics. Start by pressing the engine's start-stop button to turn the vehicle's electrical system to the on mode, which allows access to the vehicle's computer systems. Following this, utilize the HDS Honda Diagnostic System to clear any existing diagnostic trouble codes. This action is essential, as it enables a fresh assessment of the system without previously logged errors influencing the next steps. After clearing the DTC, attempt to start the engine. Observing whether the starting issue persists or if any new DTCs emerge will provide valuable insight into whether the system is functioning correctly at this moment. If DTC P16F6 appears, it implies a repeated failure. If not, the issue may be intermittent, prompting further investigation of connections at the starter cut relay 2 and the PCM. In the second troubleshooting step for DTC P16F6, begin by pressing the engine start-stop button to switch the system to the off mode. This precaution ensures safety while working on the electrical parts of the vehicle. Next, remove starter cut relay 2 from the underhood fuse and relay box. This step is crucial as it allows for direct testing of the relay's functionality. Once the relay is removed, you should perform a test to check whether the starter cut relay 2 is functioning properly. If the relay tests fine and shows no faults, you can proceed to the next step in troubleshooting. If it fails, replacement of starter cut relay 2 is necessary to restore the proper function of the starting system. This step emphasizes the importance of isolating components that may directly contribute to the malfunction. The third step in troubleshooting DTC P16F6 involves checking the integrity of the wiring that connects the starter cut relay 2 to the PCM. Start by jumping the SCS service check signal line using the HDS to ensure that diagnostic capabilities remain enabled. Once this is set up, disconnect the PCM connector A, designated as 51P, which connects to the control module governing engine operations. After this disconnection, press the engine start-stop button to select the on mode, setting up the vehicle's electrical systems for measurement. With the system in this state, measure the voltage between specific test points. The test circuit involves looking for voltage in relation to ST cut RLY2CL, with test point 1 being at PCM connector A, 51P, pin number 11, which is typically colored orange, and test point 2 being the vehicle's body ground. If the voltage reads 0.1 volts or less, it indicates the wire is intact and functional. After executing the necessary repairs related to the DTC P16F6, the final repair verification is a crucial step. First, confirm that the DTC no longer appears when conducting a new scan using the HDS. If the DTC has been cleared and does not return, it indicates a successful resolution of the issue. If an update to the PCM was necessary due to outdated software, ensure the new version is installed and operational. Alternatively, if substituting a known good PCM was the approach taken, replace the original if the new module resolves the issue effectively. Following these changes, check the overall functionality of the starting system, including the ability to start the engine under various conditions. Consistent success in starting the engine confirms that the repairs were effective and that the vehicle is now in optimal working condition. Although specific preventive maintenance tasks were detailed, general practices can help prevent DTC P16F6 from recurring in the future. Regular inspections of the wiring associated with the starter cut relay 2 and the PCM can help identify potential issues such as fraying, corrosion, or loose connections before they escalate into significant malfunctions. Additionally, monitoring the functionality of the starter cut relay through routine electrical testing can ensure it operates efficiently over time. Keeping the PCM software updated is equally vital, as manufacturers may release updates that enhance overall vehicle performance and address known issues. Implementing these preventive measures can ultimately save time and costs associated with repairs while ensuring the vehicle remains reliable. In conclusion, Troubleshooting DTC P16F6 requires a thorough understanding of the components involved, particularly the starter cut relay 2 and the PCM. Proper diagnosis begins with verifying problem conditions and working systematically through the troubleshooting steps outlined. Each step focuses on isolating the issue, whether it be a faulty relay, wiring problems, or issues with the PCM. Completing repairs should be followed by diligent verification to confirm the issue is resolved before concluding the maintenance process. Preventive practices, such as regular inspections and software updates, play a crucial role in ensuring long-term reliability and performance. By adhering to these recommendations, vehicle owners can effectively maintain their Honda Civics and mitigate future issues related to the starting system. Please like and subscribe to the channel. See you next time.